It is said that the boot prints of Apollo astronauts who walked on the Moon are still there. That is because the Moon is airless and so things stay as is for years. This single fact makes the Moon a scientific bonanza. For most of the Solar System's existence, asteroids and comets have been bombarding planets and their moons at a vigorous pace. Most craters formed from such impacts are no longer visible on Earth due to processes like wind and water erosion. But the Moon, being void of such processes, has preserved most of its craters in roughly the same condition for millions of years. By studying these craters, scientists infer what must have happened in the Solar System's past. Similarly, unlike Earth, the Moon lacks tectonic activity. So its internal structure is well preserved since its formation, giving scientists an opportunity to understand how interiors of planets form. Studying lunar mountains, which are formed by impacts, offer scientists a glimpse into the Moon's interior, as do the Moon's dark regions, which are solidified lava plains from the time of active volcanism on the Moon. It's not just science, the Moon also has technological and economic value. In the last 2 decades, NASA and ISRO spacecraft have discovered water ice on the Moon's poles. It is possible that future human habitats on the Moon tap into this water ice for consumption and fuel needs. Further, scientists study the Moon to understand how space radiation and micrometeorite bombardment can affect astronauts living for long periods in deep space, such as on missions to Mars. The Moon's proximity and access to resources make it a great testbed of technologies required for deep space exploration, including putting humans on Mars and beyond. For centuries, telescopes were the most cutting-edge means to study the Moon, starting with Galileo's observations of lunar craters, mountains and valleys. The advent of the space age in 1957 meant we could now send orbiters around the Moon to image and map those features at high resolution, and have landers and rovers take an even closer look from the surface. In the 1960s, NASA sent the Ranger series of spacecraft to intentionally go smash into the Moon. They sent back over 15,000 photographs during their fall, which taught us that the Moon has craters all over the place, even on small scales. This allowed NASA to select safe landing spots for Apollo astronauts. Around the same time, the Soviet orbiter Luna 10 revealed local variations in the Moon's gravity field. These anomalies have caused spacecraft to unintentionally crash onto the lunar surface and had to be avoided for having safe Apollo landings. Later, NASA launched the Lunar Prospector and the Twin Grail orbiters in 1998 and 2011 respectively to make detailed gravity maps of the Moon. These maps have helped scientists see features beyond the lunar surface and better understand the Moon's structure. From 1969 to 1972, 12 astronauts walked on the Moon as part of NASA's Apollo program. Apollo science experiments provided insights on how the Moon formed, whether it had a magnetic field, the nature of its volcanism and more. Humans have not been back since, and the Moon remains the only world besides Earth we've ever visited. In 2013, NASA launched the LADEE orbiter to probe the dust environment around the Moon and thus help assess its threats to future astronauts and human settlements.